Hello everyone. In this video, we are going to discuss very important examples based on some degrees of vertices theorem, right? Okay. Now look at this question. Which of the following is a simple connected graph? Which of the following is a simple connected graph? There are four options they provided. Among four options, we have to choose the option which is providing simple connected graph. Okay. Let me check is first one is a simple connected graph or not. A graph with 12 vertices, 28 edges, and the degree of each vertex is 3 or 4. Degree of each vertex is 3 or 4. Will such kind of simple graph exist or not? We'll discuss whether it exists or not. Okay. So they clearly mention that number of vertices is equals to 12 and number of edges equals to 28. Okay. And there are some vertices which are having degree 3 and there are some vertices which are having degree 4. Total how many number of vertices we are having? V number of vertices, that is 12 number of vertices. Suppose assume that P number of vertices. Okay. Suppose P number of vertices, P number of vertices are having degree 3. P number of vertices are having degree 3. Right? Then rest of the vertices means out of 12 vertices, P number of vertices completed means, and the remaining 12 minus P number of vertices, 12 minus P number of vertices are of degree 4. Right? Okay, are of degree 4. Now we can take help of some degrees of vertices theorem. According to some degrees of vertices theorem, sum of degrees of all vertices must be equal to 2 times of number of edges. Therefore, P number of vertices of degree 3. Therefore, P into 3 plus 12 minus P number of vertices of degree 4 is equals to 2 times of number of edges. 2 times of number of edges. Number of edges are here 28. Okay. This is called sum degrees of vertices theorem. Right? Next. From this, we can say 3P minus 4P, which equals to minus P. 4 12s are 48. Bring it to that side, right side. So 56 minus 48, that equals to 8. Therefore, P is equals to minus 8. What does it mean? 8 minus 8 number of vertices are having degree 3. Minus 8 number of vertices are having degree 3. Is it possible to have vertices in negative number? No. Therefore, the given option A is not a simple graph. Okay, P equal minus 8, which is not possible. Which is not possible. Okay. We cannot take minus 8. Therefore, option A is not correct. Right, option A is not correct. Next, we'll discuss what about option B. A graph with 10 vertices and 46 edges. Will such type of graph is simple connected graph or not? Okay, simple connected graph or not. Let me check. So number of vertices are 10. In a simple graph, in a simple connected graph, minimum number of edges must be V minus 1 and max number of edges must be V into V minus 1 by 2. Okay. A simple connected graph will have max number of edges only if it is having complete graph structure, right? So V equal to modulus of number of vertices in a graph equal 10, then max number of edges possible, max number of edges possible equals to V into V minus 1 by 2. Because max number of edges are possible only if it is having complete graph structure. Now substitute V equal to 10. So 10 into 10 minus 1, which is 9 by 2. That equals to 45. 45. But what did they mention here? 46 edges. 46 edges. Therefore, option B also not correct. Therefore, option B is not correct. Option A is not correct. Option B also not correct. Next, look at option C. A bipartite graph with 9 vertices and 21 edges. Will such type of graph exist or not? Remember, in the last video, we already discussed that point. A bipartite graph with n vertices can have maximum number of edges n square by 4 with floor. Okay, it means that please observe what is the principle to solve this question. Max number of edges, max number of edges in a bipartite graph max number of edges in a bipartite graph of n vertices is equals to floor of n square by 4. This is a formula, you have to remember it. Okay, maximum number of edges in a bipartite graph of n vertices floor of n square by 4. But here they mention n is equals to 9. By substituting n is equal to 9, 9 square by 4, 9 square by 4, which is equals to 81 by 4, right? 81 by 4, which is nothing but 20.25 under floor. But the moment if you apply floor, the result becomes 20. But what did they provide in the question? A bipartite graph with 9 vertices and 21 edges. No, it is not possible. If a bipartite graph is having 9 vertices, means max number of edges only 20. Therefore, option C also not correct. Okay. So option B is not correct. Option A is not correct. Option C also not correct. Now, what about option D? A connected graph with n vertices and n minus 1 edges. Yes, it is true. We already seen that a simple connected graph must contain at least n minus 1 edges. Then only we can say graph is connected, right? So a connected graph with n vertices and n minus 1 edges is correct. If it is having less than n minus 1 edges, obviously it is not connected. Okay, it's a basic principle. Therefore, option D is correct, right? Okay. Next, look at next question. Right. If degree sequence of a simple graph G is a degree sequence of a simple graph G, then the degree sequence of G bar is, okay, degree sequence of a simple graph G. And by using that, we have to find degree sequence of G bar. So to answer this question, you must understand some basic concepts. Okay, the basic concept is suppose let G be a simple graph. Let G be a simple graph. Okay, and assume that V belongs to G. V is our text which belongs to G. Belongs to G. Now, you have to remember this principle. The principle is degree of V in the given graph G plus degree of V in G bar must be equals to V minus 1. Degree of V in G plus degree of V in G bar must be equals to V minus 1. Here V minus 1 is nothing but number of vertices. Okay, number of vertices minus 1. Okay, so this is a basic property in complement of a graph. Okay, this point also covered in the previous videos. Please refer that video. Okay? Now see, degree of V in G plus degree of V in G bar must be equal to number of vertices minus 1. Okay, what is the degree of V now? Suppose here they are expecting degree of V in G bar, right? Therefore, we can say here how many number of vertices we have? The total we have 5 vertices. Total we have 5 vertices. This is equals to degree of V in G bar is equals to this V indicates total number of vertices. Total number of vertices are 5. 5 minus 1 that equals to 4. Therefore, this result must be equal to 4. Okay. So degree of V in G bar is equals to 4 minus degree of V in G. Repeating this step once again. Degree of V in G plus degree of V in G bar must be equal to cardinality of V minus 1. But cardinality of V means total number of vertices. How many vertices they provided here? 5 vertices. Okay, 5 vertices. Therefore, 5 minus 1 that equal to 4. Please observe here. There are 5 vertices are there. There are 5 vertices are there. First vertex degree is 3. Last vertex degree is 0. Okay. So therefore, suppose if V is equals to 3, degree of V is equal to 3. Directly can substitute these values instead of writing individual values. Directly can substitute this value. Therefore, degree of V in G bar must be equal to 4 minus the first one having degree is 3, right? So 4 minus 3. First vertex having degree 3, and second vertex is having degree 2. Therefore, 4 minus 2. Third vertex is having degree 2, 4 minus 2. And fourth vertex having degree 1, 4 minus 1. And fifth vertex 4 minus 0. Right? 4 minus 0. Which is equals to 4 minus 3 means 1. 4 minus 2 means 2. And then 2. Again, 4 minus 1 means 3. And 4 minus 0 means 0. Generally, we can write degree sequence in the decreasing order. Okay. So by writing in the decreasing order 4, 3, 2, 2, 1. Of course, set is nothing but unordered collection of objects, right? Unordered collection of objects. Unordered collection of distinct objects is called set. So therefore, the corresponding answer for this question is 4, 3, 2, 2, 1. That is option B is the correct answer. Okay. So to solve this question, what is the basic principle we applied here? Degree of V in G, degree of V in G bar must be equal to total number of vertices minus 1. Okay. Where in this problem, they provided total number of vertices equals to 5 vertices. Okay. Therefore, 5 minus 1 equal to 4. Right? Let me discuss next problem. Let's see problem number 3. Number of simple graphs possible with 6 vertices and 12 edges. Number of simple graphs possible with 6 vertices and 12 edges. Okay. Then how to solve this type of questions? Suppose if I ask maximum number of edges possible for the given graph with 6 vertices. Max number of edges. Max number of edges of a simple graph with n vertices. Max number of edges of a simple graph with n vertices is equals to n into n minus 1 by 2. We have discussed so many times this formula. Max number of edges of a simple graph with n vertices is equals to n into n minus 1 by 2. Okay. Now for n is equals to 6, for n is equal to 6, we have 6 into 6 minus 1 by 2, which is equal to 15 edges. Right? 15 edges. So max number of edges are possible 15 with 6 vertices. Right? But how many edges they're expecting? They're expecting only 12 edges graph. 12 edges graph. Okay. Means out of 15 edges, we had to choose only 12 edges. Okay. Therefore, number of simple graphs. Number of simple graphs possible with 6 vertices and 12 edges is equals to, means out of 15 edges, we want to choose only 12 edges, right? Therefore, 15 C 12. 15 C 12. Okay. So that is the answer to the given question, 15 C 12. Of course, 15 C 12 is also same as 15 C 3. 15 C 3. Just evaluate this one, we'll get the correct answer. Okay. So what is 15 C 12 value? It is 15 factorial by 12 factorial into 15 minus 12, that equals to 3 factorial, right? So which is equals to 15 into 14 into 13 into 12 factorial. Denominator 12 factorial, numerator 12 factorial get cancelled. And the numerator we are having 3 into 2. 3 factorial means 3 into 2. Okay. By simplifying it, so 3 ones, 3 fives get cancelled. And 2 ones, 2 sevens get cancelled. Okay. Where we are having 35 into 13. 35 into 13. So 35 into 13, which is equals to 350 and 105, that equals to 455. So therefore, answer to this question is 455 simple graphs with 6 vertices and 12 edges. Right? Suppose if they ask question in a different way, instead of asking 6 vertices and 12 edges, for example, in general, number of simple graphs, number of simple graphs are possible, number of simple graphs possible with n vertices, and m edges, right? Then how do you answer this type of question, which is equals to, first see how many number of edges are possible, maximum number of edges are possible. How many maximum number of edges are possible? N into n minus 1 by 2 maximum number of edges are possible. From that we can choose m edges. So that is a formula for finding number of simple graphs possible with n vertices and m edges, right? You please remember that formula. Next question. If a simple graph G has p vertices, the simple graph G has p vertices, there are p number of vertices and q number of edges, right? Then the number of edges in G bar, to solve this type of question, the basic principle is number of edges in G plus number of edges in G bar. Of course, we already solved this type of question in the earlier. Is equals to number of edges in complete graph with n vertices, right? N vertices. Here they clearly mention the simple graph G has p vertices and q number of edges. Okay, p vertices and q number of edges. Okay, so since it is q number of edges, therefore edges in G, q edges plus, and we want to find number of edges in G bar. So number of edges in G bar is equals to the number of edges in Kn. But n is equals to here p vertices, right? P vertices. P vertices means whenever you're talking about G's having p vertices, it should be, we can also write like in a different way. Instead of writing Kn, we can write K suffix p like this, right? If G is having n vertices, the number of edges in G plus number of edges in G bar equals to number of edges in Kn. But if G is having p vertices, the number of edges in G plus number of edges in G bar is equals to number of edges in Kp. Kp means complete graph with p vertices. Now tell me, complete graph with p vertices, how many edges are possible? Obviously, p into p minus 1 by 2 edges are possible. Okay. Now I want to find number of edges in G bar. Which equal, just bring q to the right side, p into p minus 1 by 2 minus q. Okay, so therefore the correct answer for this question is A is the correct answer, right? The basic principle which we applied for solving this question is complement of a graph. Number of edges in G plus number of edges in G bar is equal to number of edges in complete graph, right? Next problem. The very interesting problem. Let G be a simple graph, simple connected graph. Let G be a simple connected graph with n vertices on which the adjacency relation is transitive. So the most important keyword in this problem is the adjacency relation. The adjacency relation is transitive. What do you mean by transitive? Whenever there is an edge UV and an edge VW, obviously there is also an edge from U to W. Then the number of edges in G. Let me take simple example to get clear idea. Suppose if I have 4 vertices, A, B, C, D. Okay. Suppose A to B we have edge and B to D we have edge. According to transitive relation, whenever we have edge from A to B and B to D, then definitely we have edge from A to D. By using transitive relation. Okay. Similarly, suppose we have edge from B to D and we have edge from D to C, then definitely we have edge from B to C also. Okay. Next, suppose if I have edge from A to D and D to C, then definitely I have edge from C to A also. So this kind of graph they're expecting this problem, right? So in that case, definitely it is forming complete graph with n vertices, right? Is it correct or not? Therefore, number of edges in complete graph with n vertices must be equals to n into n minus 1 by 2. Therefore, the correct answer for this question is C is the correct answer. We can write it as n square minus n by 2. Right? So if G is a simple connected graph with n vertices on which the adjacency relation is transitive, then definitely it is forming a complete graph with n vertices. Okay, therefore n square minus n by 2. Okay. Next, this question is based on wheel graph. I hope you remember the definition of wheel graph. Okay, a wheel graph is always obtained from a cycle graph with n minus 1 vertices. Right? A wheel graph of n vertices can be obtained from cycle graph of n minus 1 vertices by adding one extra vertex, which is adjacent to remaining all other vertices. That extra vertex which we are going to add is called hub of the graph, okay, which we already covered in the previous videos. Okay. Now see, if Wn is a wheel graph with n vertices, then the number of edges in the complement of Wn, First, let me explain wheel graph once again. Suppose if I want to draw a wheel graph with 5 vertices, imagine that I want to draw wheel graph with 5 vertices. The wheel graph with 5 vertices can be derived from cycle graph, okay? Cycle graph with 4 vertices. Is it correct or not? Cycle graph with 4 vertices. Therefore, the cycle graph with 4 vertices is looking like this. It is called cycle graph with 4 vertices. Imagine that we have vertices like A, B, C, and D. The cycle graph with 4 vertices. What are the basic properties of cycle graph? The first property you have to remember, number of edges in cycle graph with n vertices. How many edges? It must be n edges. Number of edges in cycle graph with n vertices must be n edges. You please remember this. You already covered in the previous videos. Okay. And similarly, number of vertices in cycle graph with n vertices also n only. So number of vertices in the cycle graph Cn also n. What is the length of the cycle? Length of the cycle also n. Okay. Of course, we don't want to recall all the properties now. So this is a basic idea. Now, how can I construct wheel graph with 5 vertices? I can take help of C4. Okay, I can take help of C4. Like A, B, C, D. Now I can add one vertex. This newly added vertex is called generally hub. In computer network terminology point of view, it is called hub. Now this newly added vertex E must be adjacent to remaining all other vertices. Adjacent means two vertices are said to be adjacent if they share common edge. Okay. Therefore, E is adjacent to A E is adjacent to A. Similarly, E also adjacent to D, E adjacent to C, E also adjacent to B, like this. This is called wheel graph. Correct? Wheel graph with 5 vertices. Okay. Remember this one. It's a wheel graph, 5 vertices. Now come back to the question. If Wn is a wheel graph with n vertices, then the number of edges in the complement of Wn. Complement of Wn. Suppose if you want to construct complement of W5. Complement of W5. So how we are going to construct a complement of W5? So we can take 4 vertices, right? Which is equals to A, B, C, D, and in the middle we have E. Okay. The complement is nothing but, please look at here. A to D, there is an edge. A to E, there is an edge. A to C, there is no edge. Is an edge from A to C? No. Therefore, I can draw an edge from A to C. I can draw an edge from A to C. Okay. So A is adjacent to D, A is adjacent to E, A is adjacent to B, but A is not adjacent to C. Therefore, in the complement of a graph, definitely I can draw an edge from A to C. Similarly, D vertex is adjacent to C, E, A, but not with B. Therefore, I can draw an edge from D to B. Okay, D to B. What would be B adjacent to A, E, C, but not D. Therefore, I can draw it from B to D like this, which we already drawn. Okay. It means that this W5 complement contains two parts. Two parts. What are they? One is isolated vertex. E is the isolated vertex, and another one is it is a complement of C4. For example, if I want to consider complement of C4, tell me what is the complement of C4 now? I can simply remove this property. It is not required now. Okay. What is the complement of C4? If I consider complement of C4, we have 4 vertices like A, B, C, D, right? A, B, C, D. Now A to D we have edge, A to B we have edge, but in complement A to D we don't have edge, A to B we don't have edge. We will have edge from A to C like this. Similarly, in complement we have edge from B to D or D to B like this. This is a complement of C4. Okay. What did you notice from this? See, complement of W5 bar contain two parts. What are the two parts? One is isolated vertex. Another one is complement of C4. Complement of C4. In general, I can write like this. Wn bar contains an isolated vertex, and Cn minus 1 complement, right? Cn minus 1 complement component. That is called, that we can call it as component. I hope you understand what I'm saying. So clearly W5 contain one isolated vertex E, another one is C4 bar. Is it C4 bar or not? C4 bar. C4 complement. Okay. Right. Now what we are going to discuss now. They're asking number of edges in complement of Wn. Means that we want to find number of edges. Obviously, isolated vertex don't have any edges. Isolated vertex do not have any edges. Therefore, we want to find only number of edges in Cn bar. Right? Therefore, here I can say the number of edges in Wn bar must be equals to number of edges in the complement of Cn minus 1. Right? The number of edges in complement of Cn minus 1. Because isolated vertex do not have any edge, right? Therefore, number of edges in Cn minus 1. Now, our duty is to find how many edges are there in Cn minus 1 bar. How many edges are there in Cn minus 1 bar? Observe how I'm going to find. I'm going to evaluate the problem here. Number of edges in cycle graph with n vertices plus number of edges in cycle graph with Cn bar. Cn bar is equals to number of edges in complete graph with n vertices. Is it correct or not? It's a basic principle. number of edges in any graph plus number of edges in its complement is equals to number of edges in complete graph. But here we are talking about Cn bar, Cn minus 1 bar, right? Cn minus 1 bar. Therefore, in the place of Cn, I can replace like this. That is number of edges in Cn minus 1 plus number of edges in Cn minus 1 bar must be equals to number of edges in complete graph with n minus 1 vertices. Correct? Which implies, now tell me friends, how many number of edges are there in the cycle graph with n minus 1 vertices? So as I already explained the basic property, number of edges in cycle graph must be equals to n. Okay, it is also equivalent to number of vertices in cycle graph. It is also equivalent to length of the cycle. Length of cycle. This is a basic principle in cycle graph, right? You please remember that. The basic principle in the cycle graph. Correct? Now by using that, number of edges in Cn minus 1, how many we have? Obviously it is n minus 1. Therefore we can write it as n minus 1. Plus, now we want to find number of edges in Cn minus 1 bar, which equals to number of edges in Cn minus 1 bar is equals to, it is a complete graph with n minus 1 vertex. Complete graph with n minus 1 vertices. Have you remembered number of edges in complete graph with n vertices? The formula is equals to n into n minus 1 by 2. That is number of vertices, number of edges in a complete graph with n vertices. N vertices. But here we don't have n vertices, right? We have n minus 1 vertices. Therefore, the formula is looking like this: n minus 1 into n minus 2 by 2. Is it clear why I'm writing like this? Very simple. Just replace in this formula, replace n by n minus 1. Then we'll get n minus 1 into n minus 2 by 2. But we want to find only number of edges in Cn bar. Number of edges in Cn minus 1 bar. Just bring n minus 1 to the right side and take n minus 1 is common. We'll have n minus 1 is common. The remaining part is n minus 2 by 2 minus 1 by taking n minus 1 as common. Okay, then it is by taking cross multiplication, the result becomes, which is equals to n minus 1, it is n minus 4 by 2. Okay, n minus 1 into n minus 4 by 2. Therefore, the answer to this question is equals to n minus 1 into n minus 4 by 2. What is the correct answer? Option D is the correct answer. Right? So this is the way you have to solve problems by using the properties of a complement of a graph. I hope you enjoyed this question. It's a very interesting problem. Okay. Until unless you don't know the properties of wheel graph and complete cycle graph, you cannot answer this kind of problems. Right? Over? Right. Next question. See this question. A tree has 14 vertices of degree 1. 14 vertices of degree 1. Okay. A tree has 14 vertices of degree 1. And degree of each of the remaining vertices is 4 or 5. 4 or 5. If the tree has n vertices, then the number of vertices with the degree 5. Number of vertices of degree 5. So I think we already answered this type of question earlier, right? Okay. The tree has n vertices. The total number of vertices is equals to n vertices. Okay. And out of n, 14 vertices of degree 1. Therefore, tell me, in a tree, how many number of edges are possible? Number of edges in a tree must be equals to n minus 1. Then only it is connected. Please remember that. Okay. And we know the property that summation items from 1 to n, degree of all vertices must be equals to 2 times of number of edges. Number of edges. The number of edges are here n minus 1. Okay. Now degree of all vertices, like 14 vertices of degree 1, right? Therefore, 14 vertices of degree 1 plus out of n, 14 already over. 14 already over. Remaining how many? N minus 14, right? N minus 14. Degree of each of the remaining vertices is 4 or 5. Suppose p number of vertices are having degree 4. Okay, p number of vertices are having degree 4. Then p number of vertices are having degree 4, right? The remaining how many vertices we have? Total we have n vertices. Out of that we have 14 vertices already over. Remaining p vertices also over. Therefore, remaining vertices are out of n, p vertices, 14 vertices already over and p vertices also over. These are the remaining vertices. These vertices are having degree 5. Degree 5. Okay. This is sum of degrees of all vertices, which is equals to 2 times of number of edges. But how many number of edges they provided? N minus 1. Therefore, 2 into n minus 1. Okay, n minus 1. Now, by simplifying this, we'll get result is like 14 plus 4 into p plus 5n minus 70 minus 5p is equals to 2n minus 2 like this. Okay, 2n minus 2. By bringing 2n or by bringing 2n to the left side, we'll have 3n, right? We'll have 3n. And I want to find the value of, I want to find how many number of vertices of degree 5. How many number of vertices of degree 5, okay? First, we'll try to find the value of p now, okay? Which is equals to, by simplifying, 14 minus 70, which is equals to 56, minus 56, minus 56. And if you bring this side, it becomes 54. 50 minus 56 becomes minus 56 becomes plus 56. 56 minus 2, that equal 54. So right side we have 54. Okay. The left side what we are having? Left side 5n minus 2n, which is equal to 3n. 3n. 4p minus 5p, that equals to minus p. Okay. So therefore 4p minus 5p, that equal minus p. 5n minus 2n, that equal 3n. Remaining 56, if you bring to the right side, that is plus 56. 56 minus 2, that equals 54. Now 3n minus p is equals to 54. 3n minus p equal to 54. But what did they ask the question? From this we can say p is equals to 3n minus 54. 3n minus 54. What is p here? P is equal to number of vertices of degree 4. P equal to number of vertices of degree 4. But here they're asking question is the number of vertices of degree 5. Number of vertices of degree 5. So the number of vertices of degree 5 is nothing but like n minus 14 minus p, right? N minus 14 minus p. That equal number of vertices of degree 5. N minus 14 minus p. So better what I will do, I have already p, right? I have already p. I can do problem like this. So just bring p to the right side, and this 3n we can split it as 2n plus n. 2n plus n. Okay. Keep it as 2n plus n. Okay. This 54 we can split as, we want 14 here. We want 14. Of course, we can do the problem here itself instead of doing all these calculations. Directly, I can simplify it itself, but I already completed the problem. That's the reason I want to split. Otherwise, I can do in a simple way instead of doing this complex process. I can do in a simple way. I want to find only this part, right? Right. I want to find only n minus 14 minus p value. N minus 14 minus p value. Okay. So no need to do complete calculation. The simple way to find this one is n minus n minus 14 minus p of p into 5 equal into 5 plus 4p is equals to, just bring this side, that is 2n minus 2 minus 14, okay, which equals to n minus 14 minus p into 5 plus 4p is equals to 2n minus 16. 2n minus 16. Okay. But what we want to find exactly? We want to find only n minus 14 minus p. Okay. N minus 14 minus p. This is equal, these are the number of vertices. These are the number of vertices of degree 5. Okay. So which is equals to n minus 14. Let me simplify. Sorry for the mistake. which is equals to, I can write 5n minus 70 minus 5p plus 4p is equals to n minus 16. Okay. So here 5p minus 5p plus p, that equals to minus p only. Okay. Here it is 5n and I want to keep only one n. I want to keep only one n. So I keep this only one n. Okay. Remaining 4 n's are there. You can bring it to right side. Then 2n minus 16. Bring minus 4n to the right side. Minus 4n. Here I have 70. I want to keep only 14. So if I keep only 14 minus 14, remaining is minus 56, right? Bring minus 56 to the right side. That is plus 56. Plus 56. Which is equals to n minus 14 minus p is equals to. So 2n minus 4n, 4n that equal minus 2n. 56 minus 16 that equals to 40. So 40 minus 2n. Okay. 40 minus 2n. So the total number of vertices of degree 5 is equals to 40 minus 3n. Therefore, the correct answer to this question is A is the correct answer. Of course, I did deep calculations here. This much deep analysis is not required. You can also make it simple. Okay. I hope you clearly understood it. What is P here? Number of vertices of degree 4. It is number of vertices of degree 5. They are expecting number of vertices of degree 5. Therefore, directly you can find the value of n minus 14 minus p. These are the number of vertices of degree 5. Okay, right. Let me write that step here. This indicates number of vertices of degree 5 is equals to 40 minus 2n. 40 minus 2n, right? Okay. Next one. Right. So these are the varieties of problems in some degrees of vertices theorem. So in the next video, I will discuss more interesting problems. Okay. Thanks for watching this video.